safety protocols, prevention, detection, and response. Contents of presentation. Introduction. Hazards of fire. Common causes of fire. Formation of fire. Prevention against fire. Fire extinction. Firefighting equipment and installations. Emergency contingencies. Reactions of people in fire. Introduction. Fires teach us harsh lessons, reminding us of the destruction they can cause. Workplace fires are particularly concerning, posing risks to both employees and employers. It's crucial that we remain vigilant and cautious against fires at all times. Hazards of fire. Understanding fire hazards. High-temperature flames, intense heat, and flames can cause severe burns and even lead to fatalities. Toxic gases. Materials like sofa cushion foam emit toxic gases when burned, posing risks of poisoning. Oxygen deficiency. Combustion consumes oxygen, leading to suffocation due to a lack of breathable air. Hot smoke fume. Smoke and fumes generated during a fire can impair vision and damage the respiratory system. Property destruction. Fires can ravage property, increasing the risk of collapse and further harm. Common causes of fire. Poor management, improper storage, and handling of materials, along with negligence in maintaining electrical appliances. Human negligence, ignoring basic safety practices, such as proper disposal of cigarette butts or using naked flames in areas with flammable substances. Lack of fire safety awareness, improper treatment of static electricity, arson, ineffective control of access of people and vehicles. Understanding the formation of fire. To effectively prevent and combat fires, it's crucial to grasp the elements that make fire possible. Let's break down the three essential components. Fuels. Fires require something to burn, known as fuel. This can be solids like wood, cloth, paper, or plastic, liquids such as flammable liquids or greases, and gases like liquefied petroleum gas, LPG, or coal gas. Heat. Heat energy is necessary to initiate combustion. This can occur due to various factors such as an overload of electric current, improper contact of circuits, or the presence of ignition sources like cigarette butts or welding sparks. Oxygen. Oxygen is crucial for supporting combustion. The air we breathe contains approximately 21% oxygen, providing the necessary element for fires to burn. The basic principle. The fundamental principle of fire prevention and extinguishing is to ensure that the three elements, fuels, heat, and oxygen, do not exist together at the same time. By controlling or eliminating one or more of these elements, we can prevent fires from starting or spreading. Prevention against fire. Control of oxygen. Recognizing that controlling oxygen is challenging, focus on managing fuels and heat energy to prevent fires effectively. Maintain workplace tidiness. Keep the workplace tidy and free from clutter or debris. A clean environment reduces the risk of fire hazards. Proper storage of flammable substances. Ensure flammable substances are stored according to relevant regulations and away from heat sources or ignition points to minimize fire risks. Electrical safety measures. Electrical installations, including wiring and switch boxes, should be installed and maintained by registered electricians to prevent electrical fires. Machinery maintenance and ventilation. Place machinery in well-ventilated areas and ensure regular cleaning to prevent the accumulation of flammable materials and reduce fire risks. Unblock fire escapes. Ensure fire escapes are clear and unblocked at all times to allow safe evacuation in case of emergencies. Smoke lobby doors. Keep smoke lobby doors closed but unlocked to prevent the spread of smoke and fire while allowing for easy evacuation. Provide and maintain fire installations. Ensure adequate fire installations and firefighting equipment are provided and regularly maintained to respond effectively to fire incidents. Implement fire prevention checklists. Prepare fire prevention checklists to conduct regular workplace inspections, identifying and addressing potential fire hazards promptly. Promote fire prevention awareness. Raise awareness about fire prevention among employees through training and educational programs to ensure everyone understands their role in maintaining a safe workplace. Fire extinguishing methods. Smothering. Smothering involves isolating fuels from oxygen, depriving the fire of one of its essential elements. Extinguishing agents such as foam, carbon dioxide, and chemical powder are used to suffocate the fire. These agents create a barrier between the fuel and oxygen, effectively suppressing the flames. Separation. Separation aims to reduce the fuel supply, hindering the spread of fires. By removing unburnt fuels or cutting off the gas supply, the fire's ability to sustain itself is disrupted. This method prevents the fire from spreading further, containing it to the initial source. Cooling. Cooling works by reducing the temperature of combustion, resulting in insufficient heat energy to sustain the fire. Water is a commonly used extinguishing agent for this method. When water is applied to the fire, it absorbs heat and lowers the temperature, eventually extinguishing the flames. Examples of extinguishing agents: foam, carbon dioxide, and chemical powder for smothering. Removal of unburnt fuels or cutting off gas supply for separation. Water for cooling. Each method targets different aspects of the fire triangle: fuel, heat, and oxygen to effectively extinguish fires. Choosing the appropriate method depends on the type and severity of the fire as well as the available resources and safety considerations. Fire installations. Fire detectors. A fire detector is a crucial component of the fire detection system designed to alert occupants in the event of a fire. It should be connected to the signal circuit and the receiver of alarms to ensure prompt notification of fire incidents. Types of fire detectors. Heat detectors. Heat detectors respond to preset temperature thresholds or the rate of increase of temperature. When the temperature surpasses the set limit, the detector triggers an alarm. Smoke detectors, smoke alarms. Smoke detectors, also known as smoke alarms, come in two main types. Optical detectors, these detect the obscuration of a light beam by smoke particles. Ionizing detectors, these react to the interference of radioactive emissions by smoke particles. Flame detectors. Flame detectors are specifically designed to detect the infrared or ultraviolet radiation emitted by the flame of a fire. They provide early detection of flames, especially in areas where smoke detection may be challenging. Ensuring proper operation. Arrange regular repair and maintenance of fire detectors to ensure they are functioning correctly and can effectively detect fires. Avoid placing materials too close to the fire detectors, as this may obstruct their operation and delay the detection of fires. By adhering to these guidelines, we can ensure that fire detectors operate optimally, providing early warning of fire incidents and enhancing overall fire safety. Fire extinguishers. Fire extinguishers come in various types, each designed to tackle specific classes of fires. Understanding these types is crucial for effectively combating different fire hazards. Water, primarily used for ordinary combustibles such as wood, paper, cloth, and plastics, Class A fires. Water extinguishers work by cooling the fuel below its ignition temperature and suffocating the fire by removing oxygen. Foam effective against both flammable liquids, Class B, and ordinary combustibles, Class A. Foam extinguishers create a barrier between the fuel and the air, suppressing the fire's ability to reignite. They also cool the fuel surface, preventing reignition. Carbon dioxide, CO2 ideal for flammable liquids, Class B, and electrical fires, Class C. CO2 extinguishers work by displacing oxygen, effectively smothering the fire. They are also non-conductive, making them safe for use on electrical equipment. Dry chemical powder, versatile and widely used, dry chemical extinguishers are effective on ordinary combustibles, Class A, flammable liquids, Class B, and electrical fires, Class C. They work by interrupting the chemical reaction of the fire, forming a barrier between the fuel and the oxygen. Wet chemical, specifically designed for cooking oils and fats, Class K fires, which are common in commercial kitchens. Wet chemical extinguishers create a soapy layer on the surface of the burning oil, preventing reignition and cooling the fuel. Clean agent, suitable for protecting sensitive equipment such as computers, servers, and data centers. Clean agent extinguishers use non-conductive and non-corrosive gases to extinguish fires, leaving no residue behind. They work by removing heat from the fire triangle and interrupting the chemical reaction. Choosing the right type of extinguisher is crucial to effectively combating fires and minimizing damage. Assessing the potential fire hazards present in a given environment and selecting the appropriate extinguisher type ensures optimal fire safety measures are in place. Automatic fire extinguishing systems. Automatic fire extinguishing systems play a crucial role in quickly suppressing fires, minimizing damage, and protecting lives. Types of automatic fire extinguishing systems. Automatic sprinkler systems. Automatic sprinkler systems are the most common type, consisting of sprinkler heads and water supply pipes. These systems detect and extinguish fires when triggered by the fire alarm system. Sprinkler heads are strategically placed throughout the area to be protected, and they release water onto the fire once activated. Foam fire extinguishing systems. Foam fire extinguishing systems are designed to suppress fires by smothering them with a layer of foam. These systems are commonly used in areas with flammable liquids or materials. Chemical dry powder fire extinguishing systems. Chemical dry powder fire extinguishing systems utilize dry chemical agents to suppress fires by interrupting the chemical reaction that sustains combustion. They are often used in industrial settings and on certain types of fires. Considerations for automatic sprinkler systems. Proper installation, sprinkler heads, and water supply pipes must be installed correctly to ensure effective operation. Height clearance, the distance between the highest point of stacked materials and sprinkler heads should not be less than 500 mm to prevent obstruction and ensure the sprinkler heads can function properly. Hose reels and manual fire alarm systems. Hose reels are essential firefighting equipment used to deliver water to extinguish fires in buildings. The manual fire alarm system switch is typically located near the hose reel for quick access during emergencies. Procedures for using hose reels. Activate the manual fire alarm system. In the event of a fire, immediately activate the manual fire alarm system to alert occupants and initiate emergency response procedures. Turn on the supply valve. Locate the supply valve connected to the hose reel and ensure it is turned on to allow water flow to the hose. Pull out the hose a little. Grasp the hose reel and pull out the hose slightly to prepare it for use. This action ensures the hose is ready for deployment. Open the nozzle to check water supply. Open the nozzle of the hose to verify if there is adequate water supply. This step ensures that water is available before directing it towards the fire. Confirm water supply and deploy hose. Once water supply is confirmed, pull out the hose fully and direct it towards the scene of the fire. Use the hose to extinguish the fire while maintaining a safe distance. Smoke lobby doors. Smoke lobby doors play a crucial role in fire safety by preventing the spread of smoke and fire, allowing occupants to evacuate safely. To ensure effective functionality, smoke lobby doors must meet specific structural requirements. Structural requirements of smoke lobby doors. Fire-resisting period. The smoke lobby door should have a fire-resisting period of at least half an hour. This means it can withstand exposure to fire for a minimum of 30 minutes before compromising its integrity. Equipped with self-closing device. Smoke lobby doors must be equipped with a self-closing device. This device automatically closes the door after it has been opened, helping to contain smoke and fire effectively. The door should be kept closed but unlocked during normal operating conditions to facilitate easy evacuation in the event of a fire. Outward opening. Smoke lobby doors should open outwardly to allow for quick and unobstructed evacuation. This outward opening configuration prevents the door from blocking the escape route and ensures efficient egress for occupants. However, the door's outward opening should not reduce the effective width of any fire escapes, maintaining ample space for safe evacuation. Emergency instructions. Upon discovering a fire, raise the alarm verbally. Immediately alert others in the vicinity by raising the alarm verbally. Inform them of the fire to initiate emergency response procedures. Inform the fire team of the company. Contact the designated fire team of the company to ensure they are aware of the fire incident and can respond promptly. Attack the fire with fire extinguishers or fire hoses. If it is safe to do so, attempt to extinguish the fire using available fire extinguishers or fire hoses. However, prioritize personal safety and do not put oneself at risk. If the fire cannot be extinguished. If the fire cannot be controlled or extinguished, activate the fire alarm and notify the fire team. Additionally, contact the Fire Services Department for professional assistance. Upon hearing the fire alarm, close all doors and windows. Immediately close all doors and windows to prevent the spread of smoke and fire containing the fire within the affected area. Switch off equipment in use. Turn off any equipment in use to prevent potential ignition sources. If possible, the fire team will switch off the main switch without affecting the lighting of the premises. Evacuate the building. Leave the building immediately via the designated escape routes as instructed by the fire team. Proceed to a predetermined assembly point outside the building. Report to the fire team. Upon reaching the assembly point, report to the fire team to ensure all occupants are accounted for and receive further instructions. Important notes. Do not use lifts during a fire evacuation. Do not delay evacuation to collect personal belongings. Do not re-enter the building until it has been officially declared safe by the authorities.
This is all about today's topic. Thanks for watching Funny EHS Info. And don't forget to subscribe our channel to get immediate notification of our videos. Share our videos to your friends and colleagues to create safety awareness. If you have any questions and requirements, please comment in comment box.